Hello, my name is Vishal Kumar Jha, studying in Sri Venkateshwara College of Engineering. Today's topic is disk scheduling in operating systems. Importance of disk scheduling. Disk scheduling is a crucial component of operating systems that helps optimize the use of disk resources. It plays a vital role in improving the overall performance and efficiency of disk operations. Purpose of disk scheduling. The primary purpose of disk scheduling is to minimize the seek time and rotational latency, thereby reducing the access time for disk operations. By intelligently ordering and prioritizing disk requests, disk scheduling algorithms aims to minimize the throughput and minimize the response time for the disk input-output operations. First come first served scheduling. First come first served disk scheduling algorithm is a simple and straightforward approach to disk scheduling in operating systems. It operates on the principle that the requests for disk input-output are processed in the order they arrive, without any consideration for the location of the data on the disk or the distance between the current and the next disk request. Shortest seek time first scheduling. The shortest seek time (SSTF) algorithm is a disk scheduling algorithm used in operating system to reduce the seek time, which is the time taken by the disk arm to move to the requested track. The SSTF algorithm selects the request that is closest to the current position of the disk arm, resulting in a minimized seek time. The SSTF algorithm works by maintaining a queue of pretending requests and continuously selecting the request that requires the least movement of the disk arm. This ensures that the disk arm moves efficiently and reduces the average seek time. The SSTF algorithm is considered to be an improvement over the first come first served and scan algorithms, as it minimizes the seek time and improves the overall performance of the disk system. CLOOK scheduling. CLOOK is a disk scheduling algorithm used in operating system to optimize the movement of the disk arm. It is a variant of the look algorithm and is commonly used in systems with a large number of requests. In the CLOOK algorithm, the disk arm only moves in one direction, from the outermost track to the innermost track, and then back to the outermost track. It seems it scans the request in a circular manner, servicing the requests in the order they appear on the disk. The CLOOK algorithm is efficient in reducing the seek time and maximizing the throughput of the disk. However, it may cause some requests to experience longer wait times if they are located on the inner tracks of the disk. C-scan scheduling. The disk scheduling algorithm is a variation of the scan algorithm that provides a more efficient way of accessing data on a disk. It is commonly used in operating system to optimize the disk access and reduce seek time. In the C-scan algorithm, the disk arm moves in a circular fashion, scanning the disk from one end to the other. However, instead of reversing direction and scanning back immediately, when reaching the end of the disk, the arm moves to the other end of the disk and starts scanning again in the same direction. This approach eliminates the need for the arm to reverse direction frequently, reducing the seek time and improving the overall disk access performance. Scan scheduling. The scan disk scheduling algorithm is a commonly used algorithm in operating system for managing disk access. It is a variant of the elevator algorithm and is designed to optimize disk head movement and reduce seek time. The scan algorithm works by moving the disk head in one direction, servicing all requests in that direction until it reaches the end of the disk. Once it reaches the end, it reverses direction and servicing requests in the opposite direction. This back and forth movement resembles the scanning motion of a physical disk head. hence the name scan. The scan algorithm is particularly efficient in scenarios where there are high amounts of disk traffic and a large number of requests. By moving the disk head in a sweeping motion, it can minimize the average seek time and provide efficient disk access for multiple processes. Look scheduling. The disk scheduling algorithm is an improvement over the scan algorithm, which aims to reduce the disk arm movement and improve efficiency. In the look algorithm, the disk arm moves only in one direction, serving requests in that direction until there are no more pretending requests. Then the arm reverses direction and starts servicing requests in the opposite direction. This reduces the average seek time and improves disk performance. The look algorithm is particularly useful in scenarios where the disk requests are concentrated in specific regions of the disk, as it avoids unnecessary movement of the disk arm to empty region. Summary and comparison. FCFS, first come first served. Requests are processed in order they arrive. Simple and easy to implement, but can result in poor performance due to high seek time. SSTF, shortest seek time first. The request with the shortest seek time to the current position is processed first. Reduces seek time but may result in starvation for requests located far from the current position. Scan. The disk arm moves in one direction, serving requests along the way until it reaches the end of the disk. Then it reverses direction and services the remaining requests. Provides better performance than FCFS and SSTF, but may cause delay for requests located at the opposite end of the disk. Scan. C-scan, circular scan. Similar to scan, but the disk arm only moves in one direction. When it reaches the end of the disk, it jumps back to the beginning and continues servicing requests. Reduces the delay for requests located at the opposite end of the disk. Look, similar to scan, but the disk arm only moves until the last request in its current direction. Then it reverses direction and services the remaining requests. Reduces the delay for requests located at the opposite ends of the disk compared to scan. See look, circular look. Similar to look, but the disk arm only moves until the last request in its current direction. When it reaches the end of the disk, it jumps back to the beginning and continuous services requests. Reduces the delay for requests located at the opposite end of the disk compared to CScan. Thank you for watching my video. Do like and subscribe.